top down, and then make the fix that I put. Alright, so part of this is, we've talked about a lot of this, so hopefully this goes smoothly now. But part of it is just labeling, like understanding what it is that the question's asking and then labeling it correctly. So I want to do that here in these numbers 1 through 5. So the median income in Milan is $45,000. Take a simple random sample to survey 100 people and find their median is $50,000. So that first underlying number, the 45,000, in this situation, is that the population or the sample? That's the population. And are we dealing with means or proportions / percentages? We deal with means because it's asking about like it says median, but that's similar to mean. So this is the population mean, which how do I label that? Population, I mean. So you got two things inside. Am I dealing with means or proportions? So we said means, right? Alright, now am I dealing with the population or the sample? So the 45,000 is the population. So that's mu. The 50,000 is the sample. So how do I represent sample mean? Is the X bar. Does that make sense? So do the next one. So the median income in the U.S. is 45,000. What's that? Mu. And then the median income in my sample is X bar. Is number 2 biased or unbiased? That's biased. Is that like a random sample of things? Did I do that in a fair, random manner? Or did I go find people in a homeless shelter and ask their, you know what I mean? Like that's obviously going to be different. That's like the same idea if I went to like the wealthiest neighborhood in Michigan and asked like, what's your average income? That's biased. That's not representative of random. Mean weight of females at our school is X, and then I call some females up on stage, ask them to announce their weight. Announce it. That's hilarious. This announce weight is Y. So, what's X? That's mu. Y is X bar. Biased or unbiased? Biased. Why? What's that mean if it's biased? People are not going to tell you the truth. So mathematically, what happens as a result of the bias? What's true about X bar and mu as a result of the bias? They're different, right? So if it's unbiased, they'll be the same. Alright. School knows that the mean IQ in our entire school is 100. Is that mu or X bar? That is mu. Standard deviation is 10. So that is your sigma. I decided to find the data for our AP Stats class. Is that biased or unbiased? Biased. That's biased. You're supposed to be smarter than other people. I don't know if that's true. We'll see. So the mean IQ for the AP Stats class is 120, so that's X bar. And the standard deviation is 15. You would actually write this as S of sub X. And the formula for it is the one I wrote on the board. It's like the standard deviation of X bar. Don't worry too much about that right now. If you can get to population versus sample, we're okay for now. Again, biased or unbiased? Biased. How do you know it's biased? Don't tell me logically, tell me mathematically. grand sway. Does that make sense? What I'm trying to say. 51% of all the people in the world are female. What's that? P or P hat? Well, I'm sorry. Means or percentages? We just flipped it to proportions, right? So is that P or P hat? That's P. I don't know why I didn't add the sentence, but I take a simple random sample of 100 people and find 48% of them are female. Now, is that 48% P or P hat? That's P hat because that's from a sample. If my sample was unbiased, what would be true about P and P hat? It would be the same. And it might be that I just didn't take a big enough sample. Or it might be that I went to, I don't know how to even. Yes, I was trying to think of some way that wouldn't stereotype people. I went to like a girls' school and randomly sampled 100 people. Like that would be probably bad. The sampling distribution. So this is what we did yesterday. The sampling distribution is the boxes falling. That's like the main thing I was trying to address yesterday. And that's the one on the bottom there. Like that's your sample. Bias we talked about. I think we can kind of move on from that. I think we're good. So go through those four. Tell me if they're biased or unbiased. Like them. Because they're ridiculous. So number one is, that is a sampling distribution. That is a perfectly unbiased way to do it. I'm taking every possible sample of 30, averaging them all together. I would never do that. Like if I were trying to find, if I'm going to bother to take every single possible sample of 30 kids, I'm just going to like find the whole population and do it that way. That doesn't make sense to ever do. Like if I want to know your average IQ in here, I would try to find each of your IQs and average them together. I wouldn't like find the average of these four, the average of these four, the average of these four. You know what I mean? Like, that would be ridiculous. But if you did, it would be unbiased. I randomly choose groups of 20, call them in front of the stage to ask them if they've done drugs. Biased or unbiased? Biased. Why? I don't want logic. So this would be percents, right? Like what percent of you, I would figure out the true percentage of people that have done drugs and compare it to the percentage of people that are telling me they did drugs. That would be P and P hat. And if it's biased, what's going to be true about the P and the P hat? It will not be the same, right? P hat will probably be significantly lower, right? That's my guess. I don't think people would lie the other way. Like lie about it. Right, right. I don't know, some people might. Right, I'm gonna number 3 is perfect, that's unbiased, there's nothing flawed there, there's no weird thing going on. And then number 4, the average number of times you've cheated. But if you say more than one or more, you get kicked out of school. What percent of students here would be kicked out of school if that was the rule? 100% of students?
No, maybe except for Josh and Maya. There'd be cookies.
Yeah.
Right?
Okay, I'm sure they
They've copied something though, not out of need, but out of like.
Josh doesn't have it.
Like not like a test or something.
That's the thing.
Yeah, if you just like copied a homework or or something.
That's cheating.
No, they always have it done.
Maya, if you're listening, we're gonna need your report back.
That's
No.
not true. That's like Josh.
You copy homework? Is it cheating if you let someone copy it?
It's gonna be 4.5 hours.
No, no.
If you consciously let them, yes.
Then yeah, that's cheating too, right? So I mean, everyone's cheating. That's cheating.
4.5
Okay.
School would be non-existent.
Yeah, you do not have a mind like school.
This is why people hate Khan Academy. You can't cheat.
Yeah, you can.
Well, you can if you just go through like over and over
Log
again.
on to another computer with your username.
Oh my god.
No, you don't even have to do another computer. You do a different tab.
And then you can look at those answers and then you get those questions again.
That's more work than just doing it.
Not if
Now you don't want to
try
guess. Okay,
Not
now you
All right,
want
all right.
to probability.
Alright.
Definitely did
I
that.
don't want to hear it. Those are test things that you need to know.
But no, I did
That's the
better.
point.
But no, that I did better. And I like that.
Alright. Okay. Variability has to do with how spread out it is. So variability you can think about like standard deviation. And so the one way to think about this and like the way these situations matter, if I had like 800 data points and I have like the average whatever IQ of 800 people, and I put another person into that, now I have 801. What's going to happen to the average? Like it's barely going to move, right? So that's a low variability at that point because you've got such a large amount of data that one extra data point is just going to like barely move the needle. But if I have 2 people in my survey and I add a third, that can move a lot, right? Like my first 2 people could have an IQ of 60, like they barely made it to school. And then I get someone with then I get like a 150 and all of a sudden the average like it jumps a lot. So think about that when you're going through these. And try to tell me if there's a high or low variability of those 6. Basically the idea is the bigger the sample size, the lower the variability. And that's the same idea that we talked about up here. The bigger N is, the bigger our sample size, the smaller the standard deviation gets because we're dividing by a much bigger number. We're splitting the pizza into a lot more parts so everyone gets less pizza. So like for that first one, I watched someone shoot 5 free throws and try to estimate their long. So they made 2 out of 5. So therefore they're a 40% free throw shooter. Well, that next free throw they shoot, that's going to shift the percentage a lot. Or it could. So is that high variability or low? That's high, and just because it's a small sample size. Like if you look at that formula, dividing a number by 5, it makes it smaller, but it doesn't make it as small as if you divide it by 500 or divide it by 5,000. You know what I mean? I got a coin that I'm like, hey, I think this coin is weighted. Flip it 4 times and try to figure out if it's weighted or not. So maybe it comes up as 3 times, but that doesn't really do anything for me. There's a high range of outcomes there. There's a high variability because it's a low sample size. Did you guys ever have block scheduling? Anybody? Like seniors, did you have?
My old school had block scheduling.
Had black scheduling.
Block scheduling.
Monroe has
Like
that?
my sister
They
was
still have it.
Yeah, my cousin did when she was.
So that it's been a while.
Yeah,
my
my
sister
sister
was in 7th.
Okay.
block. So
Block
it's
scheduling
like,
is-
It's like A and B days.
Yeah, so-
some classes on A days.
And they're an hour and a half long, so you go like 1 through 4 on Monday, and then 5 through 8 on Tuesday, and then you just go every other day. I don't really know if it needed more explanation. So I asked 2 students. A lot of variability there. Like very easily, I could get 0% of people like this. I could get 100% of people like this. There's a huge range of outcomes. That's a high variability because I didn't ask a bunch of people. If I ask 800 students, now that's low variability. So if I ask that 800 first, it's not going to move the needle very much. So this is number 5 is high, and number 6 is low. So it's basically the sample size thing, right? Those good? And then what we've been talking about, do you remember yesterday how I changed the shape of the population? Like I made it skewed, I made it like a box, I made it kind of that random one. If I take enough data, what was the shape of the sample every single time? It was approximately normal. Do you remember that? Okay. So that's what the central limit theorem says. No matter what the shape of the population data is, the sampling data will be approximately normal. We do need a big enough N for that to happen, but we'll get into that down the road. Alright. Let's actually do problems now. See if that goes. That's where it all falls apart. No, this isn't that. So there's 2, there's sample means, sample proportions. There's kind of 2 categories that for the next 2-3 months you'll be putting everything into one of those categories. I left space up here so you can draw that graph up there. I think that's helpful to think about. So if the population has this mean, and I start taking a sample, then if we're doing it right, which we are in these, it's unbiased, so the mean of the sample and the mean of the population will be the same. The sample will just have a smaller standard deviation. So normal CDF comes back into play because these are normal curves, right? So number 1. Average ACT score, this is how long ago I wrote this worksheet, it's ACT. Do you guys know the scoring on ACT?
Yeah.
36 is perfect. Average is 21-ish.
Yeah.
What'd you say? Did you say riveting?
What? She said wow.
I said really.
Oh. I thought I was the average was 21 and you were riveting. Which, I guess it's fair, but it just felt weird. Okay. Fascinating, great. Okay, this 23.5. Put a label on it. What is it? It's a mean. Is it mu or X bar? That's mu. Standard deviation is 1.5. So find the probability that it randomly selects a student from that population. So there's 2 ways you can think about it. One is it's from the population. So I didn't take a sample. What we're trying to decide here is which one of these to use. So we're going to do normal CDF, whatever, comma, whatever. Tell the calculator the mean. But what's true about these numbers anyways? They're the same. So if I'm going to tell the calculator the mean, I don't really need to know which one of these it is. I just need to tell the calculator that number. Then I got to tell the calculator the standard deviation. So now you got to figure out which one of these to use. So basically, am I going to divide by the square root of n or not? If you took a sample, you divide by the square root of n. If you didn't take a sample, you don't. But in number 1, so you really technically can divide by the, so, get out of this. In number 1, part A, did I take a sample or am I drawing from the population? Drawing from the population. So you don't do this problem any different than we've done all year. Normal CDF, 26,9999. Tell the calculator the mean. Tell the calculator the standard deviation. Type that in. Let's see what we get. quite assume what you were saying. Did she get 0.0477? Make sure we all get the same thing there. The other way you could look at this is you could, like, some people just decide I'm always going to use this formula. Like, I'm never going to worry about if it's population or not. I'm always going to use this formula. And so what they would say is, well, how many students did I randomly select? What's the size of my sample? And I randomly selected a student. It's 1. So then this would be the standard deviation, which is 1.5, divided by the square root of 1. Well, what does dividing by the square root of 1 do? Absolutely nothing. So you can think about it as, okay, part A is 1.5 divided by the standard by the square root of 1. Or you could think about it, well, it's the population, so I'm just going to use this. You see how those two are the same idea? You really just have to understand one of them. We'll talk about it more as we go. Part B, now I'm randomly selecting 30 students. Find the average, or probability the average score exceeds 26. So this is like the main point I was trying to get home yesterday. If I'm going to find 10 scores and average them together, everything's going to like compress, right? So it's really hard to have an outlier in that situation. So up here, our mean is like 23.5. Well, 26 is like way over here. So our answer to part A was 0.0477. That's the size of this like shaded region right here. Well, when I start taking a sample, this got way smaller. So what do you think the probability I'm a 26 or higher, what do you think that's going to be? It's going to be basically 0. So that's the idea that 26 is a really good score. Only 5% of people get a 26 or better. 4.77% of people. So what's more likely? That I'll randomly choose 1 student that got a 26 or higher? Or that I'll randomly choose 10 students and they all average together and still got 26 or higher? 1 student's a lot more likely, right? Than 10 of them average together. So our standard deviation, because now we're in this tighter distribution, gets smaller. And it gets smaller by dividing by the size of the sample that we took. That's the way it gets smaller. So now this is your mean, and now this is your standard deviation divided by the square root of n. So type that in. And I never bother to figure out like the standard deviation. I just type it in like that. You know, just tell the calculator to do the division part and the square root part. Or if you have the typed out version, I just type it in like that. So don't bother like, well, I gotta figure out the square root of 30 is 5 point whatever, and then 1.5 divided by that. You can get a rounding issue because Riley will put like 10 for some reason because it rounds to 10 somewhere. So you get this, well, what does that mean? That's a super tiny number, right? Like that means move the decimal 20 spots to the left. So there's zeros all the way over there, and that's what we kind of expected, right? So this one is 0. What's that? You could just write 0. Yeah. Once you get past like 4, just write 0. So which of those has a higher probability, part A or part B? Part A. And the reason is, how can I write this? The larger sample, larger the sample, so the larger the sample, the more likely the data is to be near the mean. Everything pulls to the center when I start taking samples. Does that phrasing make sense? I'm trying to describe this up here. 26 is kind of an outlier. And when you start taking samples and your distribution gets smaller, well, it's almost impossible to get outliers. Questions on one then? Try two. Up here in part B, where I put a mu there, you are also allowed to put X bar there. Why can you put either one? They should be the same. So down here I wrote X bar, but I could have just as easily put mu. So this one just straight up told me 0. So you guys got, like, it didn't even give me the e to the negative 20. It was like, no, screw you, it's just
We were all like,
So in part B, this is what I was trying to say above, which might make more sense now. Some people will look at it and go, well, standard deviation was 2. I'm going to divide by the sample size. So I'm going to divide by the square root of 1. That doesn't change anything. So you're welcome to write a 2 there, or you're welcome to think about it as 2 dividing by the square root of 1. Suppose that kind of gets at what you were asking, right? That one I got 0.0660. Agree? Number 3. Basically 0. You guys get what I'm getting? Alright. That's all I got for today. Don't forget you have con due on Tuesday. So you know how to do half. Well, I'd say a little more than half now. So there's sample means, which we just did. There's sample proportions, which we'll do Monday. And then I'm trying to hook you guys up with taking the test on the second day. So as long as there's no snow days. So fifth hour will take their test Wednesday, and you'll take your test Thursday. Because it's the 1, 2, 3, 4 of Thursday. Michael, what's up?
You got it correct.
She's